Please speak up if you got questions. And if anybody puts a question in the chat, please, somebody, please speak up, because I got to switch back to the emails. There we go. All right, so let's go to Tri-County Tech. Got a bunch of questions to go over. They're not bad. Good many of them are test questions. Homework questions that are good test questions. There we go. Hold on just a second. 120. There we go. And I already put them in order. But I think there was one out of place. There it is. 6.15. It was out of place. I tried to move it. And it wouldn't let me move it. So I'm going to go ahead and do 6.15/3. 6.15/3. First of all, is it a question that I would put on a test? Probably not. Okay. Let me read the question first. It says, determine whether the random variable is discrete. Okay, discrete or continuous. So you should be able to do this. In each case, discrete means counting. Continuous means what? Starts with an M. E, A, S, U. Anybody jump in anytime?
Measure.
Thank you. So that's discrete. So that's counting, like households. And this is measuring like noise level of a household. Okay. In each case, state the possible values of random samples. A number of people with type A. Tell me what that is. Are you measuring people or are you counting people?
Counting.
You're counting, so that's discrete. Okay, now this is something discrete and continuous comes from Unit 1. All right. And the time required to download a file from the internet, discrete or continuous? Well, let me ask you a question. If me and Miss Woodward download the same file, me at my house and her at her house, are we going to download it at the same amount of time?
No.
No. So if it's not the same amount of time or the same number, then it's continuous. And time is always positive. Y'all ever heard of a negative 2 hours? So time is always positive. Okay. Continuous is not 1, 2, 3. So this is a contradiction right here. Is that it? That's a good, okay, this is a good standardized test question. So if some of y'all are getting ready to take a placement test or a practical test or an employment test or whatever, this would be one that would be on there. They might ask for eggs in a refrigerator. Eggs in a refrigerator would be discrete. How much milk is in the refrigerator? As far as gallons, that would be continuous. Because you don't count gallons 1, 2, 3, 4, 5. You count gallons like half a gallon, 3/4 of a gallon, 0.666 of a gallon. Okay, so that's a good test question. It's a good gimme question on the test, but it's also a good standardized test question. So let me erase that one. Next, I think, yeah, that's 6.2. I think these are in order. All right, I got two 6.118s/7. So I've done number 3 and number 7 of your homework. I don't feel like I'm doing your homework when I got to jump between them. When I'm doing one after the other, I feel like I'm doing your homework. No, that's 6.2. I'm sorry. I thought I clicked on this one. 6.1, 18/6. 6.1, 18/6. First of all, is it a test question? Oh, yeah. Anything with one of these is a test question. Now, I'm going to do mine on Excel because you don't want to have to do it by hand. Either do it in your calculator or do it by hand. All right? So go ahead and punch those in your calculator or click on the little do-jigger, no, I'm sorry. Go to Excel and punch these in your Excel. I'll give you a minute to do that. I'm going to mute my mic for a second. Now, I'm not worried about what the questions are asking because I'm going to tell you what I want you to do on the test. Okay? Cortisol. Here, put it back. Okay. So I'm going to go to the handy dandy, move my pivot, move that over here. And y'all should be up. Now let's do it. Let's see if it'll go take it to Stat Crunch. Let's go to Stat Crunch. It'll do it in Stat Crunch too. If you're doing it for homework. And you just go to Stat and go to Summary Statistic. Columns, X, and P of X. Well, I don't know if I know how to do it with here. Hold on, data. It should be summary statistics. I'm looking. Hold on just a minute. Yeah. Graph, you should be able to graph a scatter plot. That's not a problem. Scatter plot, your X, and your P of X. So go ahead and graph this. Go ahead and do a sketch. There you go. It goes right here, then it goes up, then it goes down. So it looks like it's skewed right because a lot of the data is on the left. Here's the center. So it looks like it's skewed right, which means most of the data is on the left. Okay, so that's what the graph looks like. So do a sketch of the graph real quick. I'll move that over here. Well, it's not going to let me. Okay, I'm going to hit Stat, and it should be linear or summary statistics, columns. I'm kind of unsure on how. There's the two columns. Maybe I just need to hit compute. You must select at least one value for select columns. Okay, and now compute. I don't know if this is right because I think they just did X. I thought they were supposed to do both. Let me hit both and see what happens. Stat, summary, columns, there and there. No, so it's just going to do one. So I guess it's asking which one is the dependent variable or independent, and that's always going to be X. Let's see what we get. Jot down those answers, and we'll see. All you're interested in is the mean, 2.5, and the standard deviation, 1.9. That's all you care about for this test. Mean and standard deviation. So write those down. Y'all got those two down? Somebody say yes so I can go on.
Yes.
Okay,
Yeah.
thank you. All right, now I'm going to Excel so I can actually do it and show y'all how to do it. Now we did this, we covered this in the video yesterday, which is Tuesday. So most of y'all should be able to do it. I don't know why it's taking so long. That's it. I don't know why it's taking so long to pull up Excel. 263. Yeah, that's it. I'll make it a little bit bigger so y'all can see it. There you go. Make it a little bit wider. And center it, because I can't stand for it not to be centered. A little bit of, what do you call it?
OCD.
Yep. All right, so we know the formula. Remember the formula. The formula for the mean is equal to the summation of x times what? Everybody wrote this down the other day.
P of X.
Times P of X. So that's all you got to do for the mean. So I'm going to make this one up here, I'm going to make it a little bit bigger. I'm going to make this column a little bit bigger, and I'm going to call it X times P of X. I'll do the first one for you in my head. It'll be 0. Aren't y'all impressed?
I am.
I'll tell you what. Oh, somebody was in your yard the other day, Mr. Yates, and I honked at him. I don't know if it was you or your daddy. I don't know.
No, it wasn't me.
It wasn't.
I'm not over there a good bit. I stay with my grandpa some, so I'm like back and forth.
That must have been your dad, I guess.
Yeah, my stepdad probably.
You got like 3 little brothers and sisters.
Yeah, I have 2 little sisters and 1 little brother.
Yeah, they were running around the yard. I think he was beating them with a bat or something. Yeah. I threw a beer bottle out there, but I didn't hit anybody. All right. I'm joking. I got a dark sense of humor. All right, there you go. Now, what do you do? What do you do to all those numbers?
Add them
Sigma,
all up.
add them all up. So I'm going to go down here, and I'm going to put mean, and then I'm going to go here. I don't know why this thing is not leaving. Is there any computer gurus out there? Why is this is supposed to be on all the time? I don't want to collapse it. There we go. You know what? I'm amazing. All right. So summation of all those, enter. Okay, somebody write. Okay, so that mean on that previous was not correct. This is the correct mean, because I don't know how to do stack crunch that much. I know how to do it with X and Y, but evidently it didn't like, I think I picked the wrong one. All right, let me hit grid, because I don't like the way that looks. All right, who's got a question on that? That's how you find the mean. And they're going to ask you for the mean and the standard deviation and graphing it. You want to graph it? Let's highlight this. Go to insert. And did they do a box chart? What they just did lines, didn't they? So I'm not going to pick the scatter plot. Let's see, I guess I'll do a bar chart. Not box and whisker, I don't want that. No. I'll just do a chart plot. There it is. See, again, you've got, I'll take my handy dandy line maker because I'm trying to impress y'all. Well, there we go. And I'm going to take my ruler. There's the line maker. And we're going to go from here. And it's not working. There we go. And of course, it drew something it wasn't supposed to. Damn Russians. I don't know why. I think I know what the problem is. I think the problem is, I think my computer is a little bit old. I think that's the problem. So they may have it. Do they have the lines like this on the homework problem, or was it just lines going straight up?
I think
Just
it was
lines
just
going
lines.
straight up.
Yeah.
Okay, well, we'll take my line and I'll put, there's one line, there's two lines, there's three lines, there's four lines. I can hardly draw that one. Okay, I'm not going to try that. Y'all get it. There it is. Okay, there's the graph. All right, let's do standard deviation. How do you do standard deviation? Well, we know that let me get rid of that. We know that the mean is equal to the summation of x times p of x. So let's write that down again. And y is I must have translucent on, which I can't tell because it won't show a check mark there. So I just have to imagine there's a check mark there. And now let's do mu. Yeah, there we go. Is equal to the summation of x times p of x. And that's mu, that's the mean. Now, the variance is equal to, I think it's what? The summation of x squared times what? P of x, and then minus mu what?
Squared.
Squared. And then, of course, the standard deviation
Square root.
is the square root of the variance. God, you were actually listening. I'm not used to that. There we go. So we need another column. And what is that column going to be called? X squared, Hubert. That's right, class. Thank you for your input. I'll do the first one for you. I believe it's going to be 0. I'm amazing. And now we're going to take x squared and multiply by what? P of x. So I'm going to make another long one here. X squared times P of x. That's why it's always good to make sure you read your formulas. Students nowadays, they don't read the formula. They just look at it, and if they don't understand it, what do? So you got to read the formula. So x squared times p of x, so that's going to be equal to x squared times p of x, and copy that down. Hit Control C for copy. Put it right there and hit Control V. So I'm going to highlight this. And we're going to highlight that blue. And I can't, for some reason, something's wrong with I can't highlight. Ever since I put this program on here, I can't highlight. So we'll just highlight it with this. So I'm going to highlight this magenta. And that number is right there. So now read the formula. What are you going to do to get the variance? Somebody read the formula for me and tell me what you're going to do. Just call that the magenta block. What are you going to do? I want you to read the formula. Somebody read it.
Subtract mu squared.
Okay, you're going to subtract mu squared from the magenta block. So there's the magenta block. And it's not picking that. Why? Oh, I know why. Minus parentheses 0.937 raised to the second power. And that's right there. 1.427 minus, that's 0.937 squared. Read the formula. And now the standard deviation is equal to the variance raised to the 1/2 power, or the square root. I just used 0.5 because it's easier. And write those numbers down because that is the numbers that are important to you for a test. I can't highlight them for some reason. We used to highlight them green because that means that they're the answer, but for some reason I can't highlight after I downloaded this IPvo stuff. I can't highlight, so I'm sorry. Let's see. I can take everything is running slow on this computer today. And I just rebooted it. A rectangle, and take that rectangle. See, everything's running so slow. Rectangle. I was going to color it green and put around it, but anyway, that's the answer. Oh, now it switches over. Thank you. Takes only 15 minutes. Yeah, something is really up with this thing today. I don't know. It's not doing anything I'm asking it to do. And then it goes back. Okay. Oh, there it is. Whatever. I'm not going to worry about it. Okay, so that's your answer. So somebody write those numbers down. 0.937, 0.549031, and 0.7409663. And let's go back to the question. What? Okay, so which one? It looks like, well, there's the graph. It's already graphed right there. And we said that the first two were real high. So none of these look like that. So, and somebody tell me, it says round, do not round. So somebody tell me, and I told you it looked like it was skewed right because all the numbers are over here on the left. And the center is right about here. So this one would be skewed left. This one would be the kind of neither. This one would be skewed left. And this one is skewed right. So that's why that one skewed right. Somebody give me that number for the mean.
0.937.
0.937. It says, oh, compute and determine the mean. Well, there ain't no such thing as 0.937 marriages, so you're probably going to say 1. I'm going to say 1 and see if they like that. Okay, so we'll do 0.937. I don't like that. Do not round. I don't like that. Okay, which of the following interpretation of the mean is correct? Blah, 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 blah. The observed marriages will equal to the mean number of marriages for most individuals. If any number of individuals age 15 or older surveyed, the observed number of marriages will be less than the mean number. And many individuals age 15 we surveyed, one would expect the mean number to be mean. It's either A or D.
It's D.
D. Good. So remember that. If many individuals age 15 or older, that's where this comes from, were surveyed, this one does not have 15 or older. That's why, because both of them say about the same thing. Would expect. Expect is a good probability word. Okay? Expect, that's one of those words that don't hold you down. The number of marriages to be the mean of the random variable. Check answer. So, okay, there's our standard deviation. Somebody give me that one. Round to 1 decimal place. The 10th. What is it?
0.7.
And that should be it. Ding. Okay, what is the probability that a randomly selected individual was involved in 2 marriages? We'll go up here. 2 marriages is point what? 133? They just ask you if you can read the graph. Oh, come on. At least. What does at least 2 marriages mean? That means your lowest number is what?
2.
2.
2. So that means I'm going to add these 2 up and take it away from, unless you want to add all these up. And you can if you want to, but this is 0.7, oh, whoa, 0.837. So take 0.837 away from 1. What do you get?
I got 0.163.
0.163. That should be the answer. Or you could add all these up. You could add 1/3, that's 13 cents plus 2 cents is 15 cents. So that's 15 plus the 3 and 4 is 7. And that'll be 12, 13, bring that up to a 14. So that'd be 16 cents and whatever that would come out to be a 3 here. So 16 cents and then a 3. Is that it? Now, this is not a good question for a test because it has too many parts, but if you can do this question, you can handle pretty much any of 6.1 question on the test because each one of these is a good test question. Do you understand what I'm saying? The question, the whole question in total is not a good question because it's too time consuming. But each one of these questions is a very good test question. The test question I like is give you this table, give you this probability distribution, graph it, mean, standard deviation. That's what I'd like for you to be able to do. Next. Oh God, what a surprise! They logged me out. And that was this one. 6-1-18. I think we just did that one, didn't we? There are 2 18s. I think there was, wasn't there?
Yeah, I think that's
okay.
what we did.
I'll do it, y'all. That's fine. Don't disrupt class. Yeah, that's the same one. All right, so I'm going to go to the next problem. 6.123, we got two of them. 23/7. Same type question. I'm looking, what is the probability that a randomly selected had four live bursts, or fourth live burst? Where's 4? 0.115. 0.115. Fourth or fifth. What's 0.115? What's 11 cent plus 9 cent? 20 cents. So it's going to be 20. And then that 9 and 5 is the 0.214. Somebody help me out. Yeah. 0.214. Add those two together. 6 or more. Somebody add that. That's 2 cent. That's 2 cent. And then 1 to make it 5 cent. 9 cent. 0.098. Yep. If a 47-year-old, blah, 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 how many bursts would you expect the mother? Well, we're going to expect means average. So we got to average all these. So let's take our handy dandy Excel spreadsheet, make it small, move it over here a little bit, go down here and do 0, 1, 2, 3, 4, 5, 6, 7, 8. Zero is 0. 0.237, 0.285, 0.166, 0.115. That didn't look okay. 0.099, 0.023, 0.027, and 0.048. I'm gonna check that right quick. Make sure it's a binomial distribution or polynomial. Doesn't look right to me. Let's check, make sure I didn't type. I think I typed in something in wrong. Hold on. 0.048. Yeah, that's okay. 0.048, 0.027, 0.023, 0.099. There it is. 0.115. There we go. All right, so we've got X, and we've got what? P of X. All right, I want you to take your time. Let's take about 1 minute, and I want you to give me the mean and the standard deviation. Take a minute and work it. I'll go ahead and graph it for you. Insert. I'll do a line graph. There you go. So that's what it looks like. Skewed what? Skewed right again, because your hump is on this side and your middle is right around here. So it's skewed right, which means all the data is on the left. So we'll put that over here. And we need to get X times P of X. So X times P of X going to equal, let's see, we need to put this in the calculator. 0 times 0, I have no idea what that is. And we're going to add those up. Oops. And Control C, Control V. I got 2.971. What'd y'all get?
That's what I got.
Good job.
Yeah, me too.
Y'all are winners. Oh gosh. Okay. Where's my bold works, my underline works, my center works, but just not my fill. That's interesting. Now I need x squared. X squared equals here. Copy that down. And now I'm going to do x squared times p of x. X squared times p of x. And add that up. Control V, Control C, Control V. Now that is my numerator. That is part of my numerator for my variance. So I'm going to put right here, mean is equal to this number. And then variance is equal to this number minus this number, parentheses, squared. That's your variance. And your standard deviation is equal to that number raised to the 0.5 power. All right, so copy those down. You got your, basically this is a test question. You got your graph, you got your mean, your variance, and your standard deviation. And the reason I don't care about the variance, but some test wants you to do the variance because they just want you to look at a question differently. They might ask for the variance. So write those down so you can give them to me. Let's pull up our homework question. Oh, it just asked for the mean. So what is round to 1 decimal? That's going to be I got 2.9 or 2. Well, no, I got 3.0. Yeah. I got 3. Yeah. So let's see what that might not be the answer. There we go. Evidently someone typed in that answer of 2 point whatever. Okay, remember when you see expect, life expectancy or expect, that means they want the average. Is this a good test question? It's okay. I don't like the way they asked you this. I don't like the way they asked you this. Why don't they just tell you to find the mean? But, all right, 23, that goes out. 31, last one in 6.1. 31. Yuck. This one's the long one. Okay, this is not a test question. But you do it the same way you do it, expected They want you to find, they're going to ask you to find the mean somewhere. Okay. But for right now, they're saying that the grand prize is 15 million. Okay. So that means you're going to put 15 million right there. So if you wanted to copy this over, you would copy it over in Excel and you would put 15 million in that top spot. Hold on a second, I'll put it in there. Well, it's not coming up. I don't know what's going on with this calculator. I'm at this computer. Open in Excel. Oh, there it is. And they're going to. There we go. And I'm going to make it a little bit bigger for y'all. Oh, it already puts 15 million in there. Okay, it did it on its own. Heck, how big is that top one? Format. There we go. So I don't know if they want you to find, let's go ahead and find the mean. So I'm not gonna do all the filling in. I'm just gonna take that and multiply by that, enter. I'm gonna copy that down. And then I'm going to hit the sum button and enter. So the mean of this game is 0.29, positive 0.29. So that means you're going to win something. Doesn't necessarily mean you're going to win a lot. But what if it came out with a negative? If it came out with a negative, that means you're playing a game that's not very winnable. Okay? If you're playing, if you've got a negative right here, that's not good. But we've got a 0.3 and it's positive. So that means we could be winning something. Now let's see what this question's asking, because it says if the grand prize is 15 million, find and interpret if the ticket cost $1, what is your expected profit? Well, this is kind of like, it should be like the life insurance question. Let me see if they do the same thing. Yeah, I did that. And there it is. We got 0.29, I think, or something like that. So this means that on average, you will win 0.29 per lottery ticket. And then they take the complement. And you're suspected to lose profit for one ticket is 0.71. I'm just looking to see where they got that number right there. Oh, that's what somebody put for an answer. Okay. I thought that was what they were getting. I'm sorry. All right. So the expected should be, what do we get? Point what? We got 0.29, which is 0.3. So it's a positive. So I'm going to put 0.3 right there. And remember, that's your average. So on average, you will win $30 per lottery ticket. To me, this question don't make much sense, so I don't put it on the test. The expected profit from one ticket is
0.7.
I thought it was
Or
0.7,
negative
but you're going to lose.
0.7.
It's gonna be, I thought you were gonna, no. It's gonna be negative 0.7, isn't it?
Yeah.
It's negative 0.7 because you do it backwards. There we go. And to the nearest million, how much should the grand prize be? Oh gosh, you're gonna have to set that whole thing equal to, yeah, to the nearest million. How much should the grand prize be so that you can expect a profit? Well, I'm going to show you what, I'm not going to write down what they do. They're going to set the whole thing equal, the whole equation equal to your outcome. Let me show you what they're doing. Continue, 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 continue. They're going to set the whole equation. Let's see, where is it? Yeah, to the mu minus 1. Okay, let me keep going. There it is. Mu minus 1 is equal to the whole equation. All right. Remember, they don't give you the number 1 prize. They give you one in the question. But when you first start out, the grand prize is not known. Okay, so they're trying to figure out what it would be so that you come out would be the profit. In other words, when you get a good profit, what's the grand prize? Now, what they did here is they make that an X, okay? Make it an X because nobody thinks in terms of $G, okay? So put an X right here. And now you got an algebraic equation, okay? Because this is the only one you don't have. So technically, you could go back to your spreadsheet. Go back to your spreadsheet. And this is your other equation right here. This is the other part of your equation. So you could actually, let's see, if I took this times this and this times this and this times this, yeah. And then that would be 0.008 times x. So let me take this, and I'm just going to pull this down here. Control C, Control V. And I'm going to add these up. Wait a minute. No, it would be this one. Sorry. I'm going to add these up. Control C, Control V. If you add these up, you're going to get 0.1825. So I'm going to go over here and I'm going to say mu. I'm going to just draw it on here because this mu minus 1 is equal to how many zeros do we have at that 0.08? Give me a second, y'all. How many zeros? 1, 2, 3, 4, 5, 6, 7, 8. 8. So 8 zeros. 0.1, 2, 3, 4, 5, 6, 7, 8. And what is that? That's an 8. X. And that's what they're doing. Oh, plus. And then I got, what did I get right here? 0.1825. 0.182509207. And you have nothing but an algebraic equation right there. Now let me bring up the handy dandy. And that's what they should get right here. It should be different numbers, but continue. Say right here, when you do the math, you're going to get X on one side, and then you're going to get is equal to a BA amount of what? Money. So let's finish this problem. I've got it set up. Wait a minute, hold on. I'm looking to see how they distributed. $10,000 times point, yeah, plus 3 plus 1, 0 times 9.3, yeah. Yeah, this problem is really not a good problem, but we'll work through it. And they set it equal to 0. There we go. That's what I was looking for right here. There's our numbers right there. They set it equal to 0. I thought they were finding the x-intercepts. So 0 is equal to 0.00000008x plus 0.182509,207. And I'm going to subtract this, and that's going to be negative 0.182509,207 is equal to 0.00000008x, and divide both sides by 0.00000008, 0.00000008, and of course those cancel, and x is equal. Somebody do this for me. I'm not worried about the negative because all they're doing is they're finding the amount. Somebody divide that for me.
Give me 1 second.
I don't think I've got the right numbers. At 0.79, that shouldn't be negative. I think I've got a wrong calculation in there. Hold on just a minute, let me look. Or it might be just different numbers. What'd you come up with?
I think I have.
Is it a big number?
Yeah.
Okay, give it to me.
To me, it's looking like 23 million.
23 million. Even,
And it's,
or what?
well, it said to round up, so I rounded up to 23.
Okay, so in this case, round to the nearest million, so 23. Let's see what they say the answer is. They got 107. I'll have to do this one. I'm going to have to do this one because I wasn't expecting this one. I'll do this one for y'all and have it for you Tuesday, okay? I'm not going to delete this one. I don't want to waste a lot of time on this one. 1, because it's not a test question. 2, we'll come back to it. So I'm not going to delete that one. 6.2, 17/7. First of all, is it a test question? Yes, NPX. Now, I want to make a note on this one. We got to pull the calculator up. Let me pull up the calculator. Get your calculators. If you don't have a calculator, you need to borrow one. This one. And pull this back up. Pull my calculator back up and my, there we go. Okay, so we've got n is equal to p, n is equal to 20. And we went over this in class. P is equal to Tuesday, is equal to 0.8. and x is equal to 18. Now I'm going to take my highlighter and I'm going to put a highlight on this. Why? Because that means if you're looking at a number line, 0 to 20, and here's 18, do I want to go up or down, or I just want to know what 18 is? Equals means I just want to know what 18 is. So it's precise. I don't know if I spelled precise or not correctly, but I'm going to use binomial PDF. And PDF stands for precise. So I'm going to take my handy dandy calculator that I showed y'all the other day. And I'm going to hit second, Vars. Go down to binomial PDF. And type in 20, 0.8, and 18. Now remember what I said on these questions. Oops, I don't do that. That's an old calculator. I don't have to do that. And enter. And I get 0.13691. 0.13691. 13% or 14% probability. So and it says round to 4 decimal places. So that's going to be 0.1369. Is this a test question? Yes. Now remember what I told you about these questions. Is the math going to get you on these, or the reading comprehension going to get you?
Comprehension.
Reading comprehension. You got to be able to know what at least is. You got to know what at most is. And of course, in this case, they just asked you for what? Equal. And you're going to do PDF when it does equal. You're going to use CDF and a number line when you do these. Now, if you don't want to use a number line, don't whine when you get it what?
Wrong.
You get it wrong. That's a good test question. I like to put these on the test because they're short and what? Sweet. So that takes care of number 17. I'll try to get through as soon as I can so I can get into chapter 7. 27/9. 27/9. Another test question. I'm going to write it down on my handy dandy do-jigger here, and I'm going to write it out just like if I were a student. Okay? If I were a student, I'd go, okay, this is n is equal to 12, p is equal to 0.25, and x is less than or equal to 4. So I'm going to draw me a number line, and that's going to be 0, and that's going to be 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So 4, 1, 2, 3, 4. So what does this mean? That means that at most, this is the same thing as saying at most what? 4. So I need to do the probability of 4, 3, 2, 1, and what? 0.
0.
So that is, now I could type in each one and say NP0 plus NP1 plus NP2 plus NP4, 3 plus NP4 using these two right there. I could do that in the calculator, or since, what is this called? When you take this one, then you take this one and put it with this one. You take this one and put it with this one and this one. What's that called? It's called, well, just think about the Unit 1 test, the Unit 2 test, the Unit 3 test, and the Unit 4 test. If I give you an exam on all of those tests, what kind of exam is that?
A cumulative.
Cumulative. Now, I don't know how to spell cumulative, so I just put C-U-M-M, which is, I think it's U-L-A-T-I-V-E, but is it cumulative? C-U-M-M-U-L-A-T-I-V-E. Is that right?
Looks right to me.
Well, somebody check it for me. All right. So I'm not going to use this because this, it's okay if you've got time, but it's not reasonable. So I'm going to do cumulative 4, which is binomial CPD or whatever it is, CDF. CDF means cumulative. So I'm going to go back to my handy dandy calculator. Now that's how you do it as a student. You don't sit there and go, okay, well, I'm just going to type these in. I'm not going to write anything down. Yeah, well, you're going to be the one whining when you get it wrong on the test. All right, so here we go. Don't do the same mistake I did the other day. That's a P. I don't need that to be a P. I need it to be a C. So I'm going to hit second, Vars. Go down to normal CDF, meaning binomial CDF, which means cumulative. And it's usually going to be cumulative to the left, just so you know that. So I'm going to type in 20 or 12. I'm going to type in 0.8. And I'm going to type in 4.
Hubert, I thought it was 0.25.
I'm sorry, what? Oh, this is another problem.
0.25.
Okay. Thank you, ma'am. I still don't like you. 0.25.
It's okay.
That's okay. Can you handle that? All right. Second. 5. I'm sorry. I guarantee you somebody's out there going. I guarantee you somebody's, Miss Woodward, I guarantee you somebody's out there going, he's so mean to her. He's so mean to her. God, it's called a sense of humor, people. Grow one. All right, here we go. So hit enter. 0.8423. Y'all check to see if that's what y'all got.
Yes.
0.8423563239. I had to do, see, the end of the physical year was yesterday at Tri-County, so I had to do 2 faculty staff development videos because you have to do 2 of them a year. And I did one on humor in the classroom. And the guy was a professor and he'd been teaching like for 150 years. And he was like, he said, I didn't want to do this video because nobody has a sense of humor anymore. And he said he actually did a class the other day and 4 students came up and gave him a hard time and said they were offended. And he said, y'all need to grow a sense of humor. So, and that's true. People need to grow a sense of humor. I mean, this is getting ridiculous. I heard this morning, this is no joke. I heard this morning that a mascot of Boston University is going to be renamed because his actual name, The name of the mascot is Red. So if you know somebody that's named Red, they need to change their name.
I don't know. I still feel some type of way about Aunt Jemima coming off the syrup.
I'm gonna start buying up all the Aunt Jemima syrup I can and start selling it. 20 years from now, it'll be antique. I think it's ridiculous. I mean, Rhett. How many of you? I know somebody named Rhett. I know 2 people named Rhett. I mean, I don't understand it. I think we've done gone crazy. All right, next problem. I just thought that was ridiculous. So, Mr. Yates, what's your first name?
Colton.
Okay, I'm gonna associate that with something, and I'm gonna make you change your name. I guess I get Colton. You know, the first. You know, I could think of. You know, have you ever played the name 7 Ways to Set Kevin Bacon? You ever played that game?
No.
Well, I guarantee you, in 5 steps, I could get Colton name to be canceled. All right. It's ridiculous. I ain't got to worry about Hubert because Hubert is such a screwed up name. Nobody will want it. Nobody even cares if it's canceled or not. All right. 6.229/10. And so far, the 2 6.2 questions that we've went over are good test questions. Oh, this is a good one. I like this one too as a test question. It's real easy to do. I'm going to show you how I would do it. Sorry, wrong thing. N, P, X. And since this is precise, because you're going to type in each one, that's going to be binomial PDF. And you're going to type in 6.15, 0, 6.15, 1, 6.15, 2, 6.153, and so on. All the way down to 6.15 and 6. I'm sorry. Yeah, 6. All right, so I'm going to draw my handy dandy. I'm going to throw this dead marker away. And I'm going to draw me a handy dandy table. 0, 1, 2, 3, 4, 5, 6. And it says round to 4 decimal places. So somebody give them to me. What are they? What's 0? Okay, I'll do it.
Give me 1 second. I was finishing up that last one.
Okay. What is 0?
Let's see. 6 trials, right?
6.15 and 0.
0, that's going to give you 0.3771.
All right, somebody give me 1. I want different people. I don't want Mr. Yates to answer every single one of them.
6.3993.
Ooh, this is skewed right. We already got, let's see, 38 cent and 39 cent. That's already 70, what? 77 cent right there. Good gracious, we ain't got much more. Who's got 2?
0.1762.
Thank you, Miss Woodward. All right. And 3?
0.0415.
Next. We'll let Miss Woodward or Miss Billy.
0.0055.
How about Miss Billy on number 5?
0.0004.
And one last one. Who's going to get 6?
1.391.
Is that
No,
okay? That
no,
must be different
it's,
scientific notation.
I think it's 0.0000.
Oh yeah, there's a bunch of 5. There's 5 zeros first.
Okay, so that's it. So we're going to type them in, and let's see if we get them right. So 0.3771. Oh shoot. 0.3771. 0.33993. 0.1762. 0.41415. 0055. 0.0004 and 0.0000. See, that's it, I think. Yep. Oh, no, they want you to. Okay, now find the mean and the standard deviation. So go ahead and punch those in your calculator or your Excel spreadsheet. So I'm going to take my spreadsheet and pull it up. Make it small. Move it over. Go down. Good gracious, why have I got it? Y'all go ahead and keep doing what y'all doing. I'm just making mine a little bit smaller so I can do something with it. All right, so 0, 1, 2, 3, 4, 5, 6. And 0.3771, 0.3993, 0.1762, oh, it's not working. 0.3, nothing's working. I think my computer is about shot. 0.3. Okay, my computer has just decided to stop typing. So y'all type it in. I don't know what's going on.
I got it for you.
0.3. It's not working. It's not doing anything. Now it won't. It's out. I think it's freezing up. All right. Let me go. I hope I can get the. I hope I can get this back. There. Okay. Give me the. Give me the. It says round to 2 decimal places. What is it?
I got 0.90.
Come on. Hold on. I got to turn my. Point what?
90.
My number lock was turned off. Maybe why it was acting weird. And give me the standard deviation.
0.87.
And that's done on the did you do yours on the calculator?
Yes, sir.
Okay. Okay, now let's do it by hand. By hand means NP and NPQ. Okay, so I'm going to take the top. They got to give us compute the mean and standard deviation. We've got N and P, so that's going to be, I'm going to go to my handy dandy. So mean is equal to N times P, which is going to be equal to 6 times 0.15. Well, 10% is 0.6, so 5% would be 0.3, so that would be 0.9. Somebody check my math.
Yeah, that's what I got.
That's right.
Okay, now I'm going to find the Standard, okay, they want standard deviation probably next, but we'll go ahead and round to 2 decimal places. I got
It's just
0.9.
it's just 0.9.
Is it 0.9? Okay, thank you.
Yeah.
0.90. Okay, now probably they're going to want the standard deviation. Now, the standard deviation, the variance, let me do that for you. And we went over this the other day. The variance is equal to NPQ, and then, of course, what's the standard deviation?
Square root of variance.
So N and P is 0.9. So these two, that's 0.9 times Q. Well, Q is 0.8 what? 0.85. It's the complement of 0.15. So 0.85 is right here. Now, let's see, 10% of 0.9 is 0.09. Okay, so 80% would be 72 cents. Okay, all right, half of 10% would be 0.045. So that means I should get 765. Somebody check me for the variance.
I got the same thing.
765. And somebody take the square root of that, because I'm not even going to try it. I'm not Rain Man.
I got 0.87.
And everybody else get that?
Yeah.
So that's your standard deviation, 0.87. And as you can see, it's not much difference between the two. I like, oh my gosh, these people in their graphs. Draw a graph of the probability distribution. Well, somebody tell me, what did I say at the beginning of the problem?
Skewed right.
It's skewed right because all your heavies are on the left. So you're going to have 2 heavies on the left, halfway, and then. So let's see which one looks like that. Where's the 2 heavies, and then
D.
D.
It's either going to be C or D, and it looks like D because this don't work. So it's going to be D. Good God, how many more questions can you get out of this? The binomial probability is skewed right because all your data is in those first 3. Is this a test question? No. Is it got several test questions in it? Yes. If you can do this problem, 6.229, if you can do this problem, you can pretty much handle 6.2. Because that's a test question. That's a test question. That's a test question. And the graphs, you can do that on your Excel spreadsheet. But to be able to see it by your eyeballs, that's worth every penny of it. So all of these are test questions. So that's a good question for homework, but it's also a lot of good test questions. Delete. 6.235. You got 3 of these. I guarantee you this is an MPX with a whole list of things. Yeah, my computer is running. Yep. Okay, so what I'm going to do, and I don't care about A because you can, it's a finite number of times. What's the probability? I mean, what's the outcomes of you going to a gate for a plane? What's the 2 outcomes that's going to happen? Either you're there on time or you're there what?
Late.
There's no other outcomes. Yeah, you can say early, but early is on time when it comes to a plane. But if you get there 20 minutes after the gate tells you to be there, you are late. So you have a binomial outcome. A binomial outcome means yes or what? Yes or no? Black or white? True or false? A binomial means on time or what? Late. Those binomial means two. You got two outcomes. So yes, this is a binomial experiment. There's a fixed number of trials, 15 flights. You got a number line from 0 to 15. Okay? Exactly. There's that word exactly. Exactly. Somebody tell me, what are we going to use for the word exactly? Because you already got, n is equal to 15, and you got p is equal to 0.85. So what are you going to use for exactly?
Binomial PDF.
PDF. So you would type in PDF 15.85 and exactly what? 11. And somebody give me 4 digits on that.
I got, let's see, 0.11564.
Everybody get 0.1156? Well, let's go ahead and answer these questions. There are 2 mutually exclusive outcomes, success or failure. I would say that's true. Well, there might be another one. Where's another one?
Yeah, there's like 3 you got to select.
Oh, there's 3. Okay. There's a fixed number of trials. The
Trials
are independent.
And then
And
performed a fixed number.
And where's? I thought I said perform a fixed number. That should be it, shouldn't it?
Oh, there's 4 total. There are 2 mutually exclusive. The probability of success.
Mutually exclusive. 2 mutually exclusive.
Let's see.
I'm looking. I hate these wordy questions. It's not 3, so it must be one of these.
Let's see. It's performed.
It's not previous trial. E.
The probability
Okay,
of
so
success.
write those 4 down. The experiment is performed a fixed number of times, 15. Or you could say 11. Okay, in other words, it's not 11.2 and it's not 15.6. The trials are independent, meaning that one depends on the other. They're independent. Okay, the probability of success is the same for each trial. Okay, if 5 people show up at the gate late, then they're late. So it doesn't matter who they are, they're late. And there are 2 mutual exclusive outcomes. On time or what? Late. All right, now let's get down to the math. Well, if I could work this mouse, I think I'm just about ready to quit today. All right, here's the one we just answered. 0.1156. Now, what I just answered is this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I just put me a dot right there on 11. That's what I just did. What is the probability of exactly 11? All right, let's go to B. Oh, I hate when they do this. All right, move the decimal 2 places to the right, 12. They do this on every question. Okay, here we go. The probability that fewer than 11 flights. Now, this is the key right here. The reading comprehension. Tell me what fewer than 11 flights really means.
10 and below,
Good job. Why doesn't it include 11?
because it's fewer than 11.
Because it's fewer than 11. It doesn't say fewer than and equal to. It says fewer than 11. So I'm going to put fewer. I'm going to put fewer than 11. And then I'm going to put x is less than equal to 10. Or x is less than 11. Now, when you see this right here, and I'm going to be honest with you, I'm talking to the online class as well as, if you see this and you don't see this, then there's going to be a problem. And that's why you need to use the handy dandy number line. Fewer than 11 says that you cannot use 11, but you can use what? 10. Now, why am I not doing between the marks? Because is there such thing as 2.5 planes? No. That's why it's called a binomial distribution. You don't have 2.5 flights. You either have 2 or you have 3 flights. Okay, so that's why. So fewer than 11 is pink. And of course, we can use cumulative CDF, but you got to be careful. You can't pick 11. You have to pick what? 10. So this would be CDF, cumulative from the left, up to 11, but not including 11. So somebody do CDF, and that's going to be 15.85 and 10. Somebody give me 4 digits.
.0617.
0.0617. And that's going to be 6 flights, or whatever, 6 people or 6 flights. Which 0.0617. And then you're going to move the decimal 2 places to the right for the 100, and that's going to be 6. All right, what does C say? Okay, that was C. D, at least 11 flights. Okay, critical thinking here. What does at least 11 flights mean?
Yeah, that's the lowest number.
Okay, D, at least 11 flights. Okay, you should put that in quotation marks, and you should say to yourself, the lowest number is 11. I'm sorry. That's what you should be saying. You should be saying the lowest number is equal to 11. So somebody tell me what I graph on the number line. This is orange. I don't know if you, let's do blue because you can't tell that.
11, 12, 13, 14, and 15.
Okay, that's correct. Now, am I going to add 11, 12? I'm going to do NP11 plus NP12 plus NP13 plus NP14 plus NP15. Am I going to do that? Yes or no?
No.
You could.
No. Somebody tell me what I'm going to do.
Binomial CDF.
No.
Nope.
Look at the number line.
Oh, that would be PDF.
No. You don't have to use the calculator at all. Come on, people. Critical thinking here. Look at the number line. What did we just do in B?
we found out that fewer than 11 is 0.0617. So would we say
what
1?
What would D be?
That would be 1 minus
The
0.06.
complement. 1 minus. So I'm going to put 1 minus, and I'm going to take my pink marker, which I hope it shows up, and do 0.0617. And that's going to give me the blue. And I know, what's $1 minus 6 cents? 94 cents. So that's going to be 83.9383.
Yeah, that's what I got.
So the blue dots, the probability of the blue dots is 0.9383. This question, you have to read and you have to use your number line, or you'll just be sitting there staring at it. Oh gosh, 94. Between 9 and 11. Now somebody tell me, does that mean that we include 9 and 11? No. So what number, let me find another color. Green. What is between 9 and 11?
10.
10.
10. So we're going to do DE. We're just going to do just 1 point. So what's 1 point? Is that CDF or PDF?
That'll be PDF.
PDF, 15.85 and 10. Somebody do that for me and give me 4 digits, please.
I got 0.0445 or 9.
0.00449.
Yes, sir.
0.0449. Point 0.0449. Uh-oh. Check that. Was it 0.04459 or 0.0449?
No, it was 0.0449.
Okay. What did y'all get, Miss Billy? Did y'all get that?
I got that. I think I made a mistake.
Hold on. Binomial. I'm going to do PDF, so I'm going to hit second, enter, PDF, and I'm going to type in 15 and 0.85, so I'm going to put an insert, second, delete, 5, and 10. Okay. I don't know what they want. Unless they want 0.0450. Let's try that. 0.0450. Okay, I have no idea what they got. That's not right. The only thing I can think they're saying, they're including 9 and 11, and that doesn't say, look at there. What does it say there? I didn't read the freaking directions. All right, I need y'all to type in 9, 10, and 11, please. You got to do addition. I'm sorry, I didn't see the inclusive. I didn't see the word inclusive there. So that's going to be 9, 10, and 11 because of the word inclusive. Now, I did that on purpose just to show y'all to read the question. I did that on purpose. So somebody do 9, 10, and 11 and add them together. And give me 4 digits, and it should be 0.1737.
Yeah, that's what I got.
My apologies. 0.1737. Good gracious! Oh, that's just, and that's going to be what? 0.1737 is 17. If you move 2 places to the right, that'll be 17. Okay. Now, this is not a test question, but there's 1, 2, 3. I don't like E because they should put an underline or something. I didn't read it. Okay. But E, there's 4 good questions there. 4 good test questions. Okay, that takes care of 35, 35, and 35. Good. We got a little time today. We can actually work on chapter 7. So let's move. I don't have much time. I got about, what, 15 minutes?
Yeah.
That's what okay. All right, so let's go. I showed y'all the first part, which is the uniform distribution. I showed you that part. So there's uniform distribution, and I'm not going to worry about that. And there's uniform. And then we're going to get to here. Here we go. Okay, now, when we're talking about the normal curve, there we go. There is your, and write that down. If you hadn't wrote that down, if you hadn't wrote that thing down by now, I don't know what you're waiting on. That's what rule is that? Starts with an E.
Empirical rule.
Empirical rule. And like I said, if you haven't wrote that thing down by now, I don't know where you've been, because that's one of the things you have to know to get it this far. All right. You're going to be using the empirical rule as a checker. Okay. You're going to be using the empirical rule to check to see if you're in the right area. So when you're talking about the empirical rule, you're going to use it as a checker. So empirical rule. Check your work. If your empirical rule says that your answer should be around 2 and you get 6, then you know something's wrong. So we're going to be using the empirical rule on the check to check your work and to make sure that your answers make sense.
You have a work email.
You're going to be drawing a lot of bell curves in this section, these 2 sections. So make sure that you run some copies for those 1 or 2 people that actually did the bell curves that I told you to run copies of them. You might want to run about 10 or 15 copies. If you got 2 or 3 on each sheet, you might want to run them, because you're going to be drawing a lot of curves. I'm going to skip this. We're not going to do that. I want to get to the meat of the course, the 7.1 and 7.2. Okay. Area under the curve is just like probability. Okay. Area under the curve is just like probability. All right, I'm going to go back here. We're going to write this down. Go ahead and write. Area under the normal curve is just like probability. Area equals probability. Just write that down. Area equals probability. And when you're drawing the normal curve, you're going to include the mean and the standard deviation, which you've been doing that since Unit 1 with the empirical rule. So that should be nothing to you. So when you start these problems, the first thing you're going to do is you're going to draw a curve. You're going to make sure you somehow have the empirical rule present, and you can do that with little subscripts or whatever. And in the first part of chapter 7, 7.1, the first part, mean is equal to 0. Let's do 7.1 first part. The mean is always going to be equal to 0, and the standard deviation is always going to be equal to 1. And that basically gives you the z-scores that we learned how to do basically in Unit 1. So this is going to be 0, 1, 2, 3, -1, -2, -3. And then somewhere you can print out some that have the percentages like real lightly, like 0.15, 2.35, 13.5, 34, 34, 13.5, 2.35, and 0.15. That's what you should have when you start these problems. Now, again, if you want to do as I say, then if you don't want to do what I say, then don't cry when you're not being able to do as well as you want to do. Okay? And that's what this is telling you. Well, that's what this is telling you. Now this is one that is in the second part of 7.1. I don't really agree with them doing this, but you would draw this one if you had to, and you'll see this later, 22 and 200. I'll do it in another color. Let me do it in blue or a light, no, let me do it in pink. And 7.2, you're going to be seeing them like this. And you can put your 0 and your 1 and your 2 here and your 3 here, -1, -2, -3. You can do that, but in 7.2, the mean is going to be equal to 2200, and the standard deviation is going to be equal to 200. So you got to put 2200 right here, 2400, 2600, 2800. And of course 2000, 1800, and 1600. And then 0.15, 2.35, 13.5, 34, 34, 13.5, 2.35, and 0.15. And a lot of people say, well, Hubert, what do you put on the curve? And then the only thing you don't put on the curve is these, because you don't know what you're going to be given. Okay, in 7.2, or whenever we get to those problems, you don't know what this is going to be. You know the 0 is going to be there, you know the 1, 2, 3, and you know that the percentage is going to be there. And you can put that on all your curves. But when you do the 7.2 material questions, you're going to have to add another scale down here, and you can just add them and just mark out the 0, 1, and 2 if you want to. That's up to you. But that's the two type graphs we're going to be dealing with. And I don't know why they put that 2200 before, because we're not going to see that until the second part, which is 7.2. But anyway, that's what they're going to do, and you're going to draw the curve, and it's going to look whatever it's going to look like. Okay? There's the curve right there. And you see they got the numbers on the bottom. They don't have theirs divided up by empirical rule, but that is something I tell all my students to do, so you'll be ready for the question whenever they ask it. Okay? So there's the pink one we drew, except I don't have it, it's not divided by standard deviations like I do. Okay? They're just telling you, what they're telling you in these slides right here is get ready to draw the curve one after another, one after another. Okay, this is 7.2. They haven't even done an example. Okay, we're going to do some examples, and I'm just going to throw the slides away because we're already on 7.2. Let me see if they got an example of 7.1. No, that's not what I want. They didn't even give you an example in the first part. Okay, so let's go back to our handy dandy. And I know, what time is it? What time's class over, Miss Billy?
You got about 7 minutes.
2:35.
Yeah, it's 2:35.
Okay, 2:35. Okay, at least I can get through with the first part. All right. This is how it's going to ask. They're either going to ask you for area and you find a z-score, or they're going to ask you in 7.1, the first part, they're going to give you area and you find the z-score, or they're going to give you the z-score and you find the what?
The area.
Find the area. And let's call this A, and we'll call this B. If you have A, you're going to use in your calculator what's called, hold on a second, I'm having to switch from back and forth. Let me make this small and move it over. Okay, so I guess I have to make it small. There we go. You hit second Vars, normal PDF, and normal CDF, and inverse norm. Inverse norm goes with the first one. Inverse norm. Second Vars, inverse norm. And then normal PDF or normal CDF, I gotta punch it in because I always forget. I think it's CDF, but I'm not sure. Yeah, I think it is. Normal CDF, I'll punch that in. Normal CDF is with, let me do that right quick and I'll tell you if it's right or not. Normal CDF. Okay, lower is -99. I don't know why I keep using the keyboard. Don't ever use the keyboard on the computer. Negative there. And 0. And it should be 0.5. Yep. Okay, so it's normal CDF. Now, And I know I got to hurry. I got 4 minutes. So if I want to find, here's A. They say, given an area of area equals, or probability is the same thing, equals 0.6214. Okay, usually area is going to be given in 4 digits. So we know that 0, 1, 2, 3, -1, -2, -3. We know that this is 50%, don't we? We know that halfway is 50%. So 60% is going to fall somewhere in here. So we know it's going to be between the z-score is going to be between 0 and 1. So by common sense, we know that the answer is going to be between 0 and 1 because 50% is right here and 84% is right there because this is 34 by the empirical rule. So we know it's going to be between 0 and 1 because 62% falls between 50 and 84%. Now we could get technical. What's between 50? Well, 34, half of 34 is 17. So halfway would be 0.67, and that would be 0.5. So I'm going to take my pink pen, and all I'm doing is using common sense right now. I'm not doing any math. I'm just using common sense. If 0.67 is right there, then halfway between here is going to be, well, that's 17. Half of 17 is 8. That's 58%. And we want what? 62? 58 to 7. Well, that's 8, isn't it? Close to 8. Half of 8. There we go, right there. There's our spot right there. So this is 0.25. And halfway between 0.25 is 0.37. So I'm going to say it's about 0.35. Z-score of almost 0.35. Now I'm going to type it in my calculator. I'm going to type in second, Vars, inverse norm, and I'm going to type in 0.6204, 0.6214. And it's on the left-hand side because we want to know this area right here. We'll get into that later. And hit calculate or paste, and then, oh my Lord, paste and enter. And the answer is 0.3092. 0.3092. Now, was I off? Yeah, but I wasn't expecting to be right on it. I was just eyeballing it. Okay. Now, if I came out, if I said 0.35 and this number came out to be 0.68, then I knew something was wrong. So that z-score right here is 0.31. 0.31 is your z-score. Z-scores are usually in 2 decimal points. 4 decimal points is usually area. There's one type of homework question you're going to get in 7.1 homework. Okay? All right, let's shut her down. Some of y'all are going to go into convulsions. So let's go ahead and shut her down. I don't want anybody going into convulsions. Let me turn off everything. Turn off the recording and turn off the presentation.